So I think we are pretty much done with the CNN part. So then let's move on to another type of neural network called a recurrent neural network. Okay. So far, what we have learned is that this vanilla neural network, right, we mostly doing this one-to-one mapping, right? So the most commonly or widely used application is image classification, right? So we input image, we generate output, right? The label, predict which class this image is. And we also have other applications that is not follow this kind of one-to-one mapping paradigm, right? So we can have a one-to-many application, right? So the example here will be doing image captioning, right? So the input is a single image, right? But the output is actually a sequence, not just a single label, right? This is a motorcycle or other things. So actually a caption, right? So a person riding a motorcycle on a dirt road. So this is actually a sequence of the output. We can also have applications require many-to-one mapping, right? So for example, we can have the sentiment classification, right? So the input may be a sequence of words, right? So we can do this kind of sentiment analysis on some of the text from social media like Twitter, right? So we can analyze the sentiment. So this is one-to-many, right? So input is sentence, then we can output will be some sentiment like negative, neutral, or positive, or maybe different emotions, happy, sad, or etc. And we can also have many-to-many mapping, right? So the simple example is translation, right? So we can translate English to Chinese or maybe different languages, right? So this requires many mapping, right? So input is sequence, output is also a sequence. And another example for this many-to-many cases is we can also use the example of video classification, right? So the input will be a sequence of video frames, right? What we can do is we can do classification on each individual frames, right? We can do frame-based action classification. So again, the output will be many class labels, corresponding to each frame. And eventually we can do like a majority voting, right? So what is the most frequent class label has been output or predicted for all these different frames. Okay. So the sequence has been presented in different forms, right, in our daily life, right? So we have audios, right, presented as a sequence. Videos, we can also treat it as a sequence of images, right? So we also have a sentence, right, a sequence of words. And the recurrent neural network find them very useful because they can do all these, besides one-to-one mapping, they can do like sequence to one, right? Doing the sequence to sequence, right? And so they can do the mappings we discussed before. And this recurrent neural network actually also being applied to image classification, right? So basically we can build a recurrent neural network to progressively to process like patches in a specific order, right? You can slice these in a specific order and try to extract information and do the classification. And this example also shows that the recurrent neural network can, do image painting, right? To generate some of the missing or trying to generate a specific digit, right? Like the paint house numbers. Okay, so to understand the basics of recurrent neural networks, let's look at the specific application or example, right? So here we are using this slot filling as an example. So here we're looking at a ticket booking system, okay? So a user, right, maybe they type in, right, to the, interact with the booking system and typing, a sequence, a sentence like this, right? I would like to arrive Orlando on November 2nd, okay? And the ticket booking system needs to figure out two basic classes, right? One is what is the destination and what is the time of arrival, okay? So once the booking system, figure out these important information, then they can retrieve the available flights on those particular dates and to those particular destination, right? So, before we, go into the recurrent neural network, let's first think about how can we do this, right? To using the feed-forward, the simple feed-forward neural network, okay? So to do this, we can take the input, which is the words, right? So every time we can take a word a time as input, and each word, of course, will be represented into feature vector, right? We can use the word embedding to generate the machine interpretable feature representations, and then we can use that as the input to feed into this feed forward or fully connected neural network, right? In this case, and the output will be the probability that input belong to a specific slot, right? So here we have two, right? One is the destination, the other is the time, right? Okay, so to do this, right, we process each of the word, right? So we take this first word arrive and we do the word embedding to generate feature representation, and we feed this feature as input to the fully connected neural network, and we can generate this class probability for these two slots, right? So maybe we have another class called other, right? So here maybe this network predict this is other class, and Orlando we do the same, and this is being determined or predicted as a destination, and etc. Right? So we can do this using this feed-forward fully connected layer, but there's some potential problem, right? So if we look at another sentence, which is here, right? We only change actually one word, right? So changed arrive to leave, okay? Now there's gonna be a totally different meaning for this, for particular word, right? So before, arrive Orlando here is the destination, right? But now leave Orlando here, this is actually is the place of departure, right? So in this case, we are still process the word one by one without considering or memorizing the context. There's going to be problematic, right? So you will have this confusion to the model. So in other words, the network needs some memory to memorize what has been learned before, so that he knows the context, so that the later prediction can be more accurate or prone to the specific context, right? So if we remember, so yeah, so I think the point here is that for these two examples, right? So if we don't have the memory, right, what we learned before, then this will introduce some of the confusion. So the recurrent network is designed to specifically address this issue, and also introduce the notion of storing some of the values learned in the memory. Okay, so here we have some memory unit A1 and A2, and whatever we learned in the hidden layer, we can store that in this memory cell. Okay, A1 and A2, and this memory can be considered as another input. Okay, so rather just considering the this like the so-called original input here, but this memory can be also considered as additional input, right? To process the when we process the next input feature. Okay, so we can actually work through a specific example here. Let's consider all these simple feed-forward network, right? So we only have one hidden layer, okay, and these are the input, and Y1, Y2 are the output, okay? And all the weights will be just a 1, and we have no BIOS term, and the activation function is gonna be linear. And we can give it the initial value to the memory of 0, or just for simplicity, we can give it to 0. And we have the input sequence here, okay? The first one is 1, 1, right? So we can easily get this, the output of the hidden layer gonna be 2 and 2. So what we do is we're gonna store these values in the memory, trying to update the memory. Okay. In this case, when we do this, in the process the next input, which is still 1 and 1, we have the updated memory of 2, right, which is we get from the previous input. And then we process this, and we can get this output for this hidden neuron should be 6 than 6, right? We consider the input and consider these memory as additional input. So we get this output of this hidden neuron. And now for process the next sequence here, we should also update the memory value, the value stored in the memory, so we can process the next sequence. So this is how, the basic idea of using this memory cell to memorize what we learned from the previous input and use that as the additional input when we process the later input. Okay. One thing to note that is because, right, we are using this memory as additional input. If you change the sequence order, these memory, the value is going to be stored in the memory also going to be changed, right? Okay. So if we, still consider this slot filling example, right? So we can using this same network again, right? But every time we'll update this memory value so that some of the context can be remembered and the network is able to make the correct prediction. And an easy way we can, write or indicating recurrent neural networks is you can, basically have like a feedback loop, right? Because what we learn output from this neuron, we're gonna use them as the input again to this neuron, right? So you can using this simple structure to indicating this is a recurrent neural network. But if you unroll this, right, so this has this kind of connected component, then you can reuse the value stored in the memory as input to process the next input value. And if we do the comparison of these two examples, right, either arrive Orlando or leave Orlando here, and when we process the second word, Orlando, right, so although the network is the same, but we will end up with different output. It is because the value, right, stored in the memory is different, right? So this memory stored is learned by based on the input of leave, but this memory value learned and stored is based on the input of arrive. So these memory value is stored are different. So this will give the different output for these two different sentences. Of course, we can, be deep, right? So we don't have to be necessarily just one hidden layer, right? So we can build a deep network and basically each of the hidden layer, we can have the memory. And so we can also build like a deep recurrent neural network to process the sequence so that we are able to make sure that the network learns before, right, to understand some of the context so that the decision it's made can be reasonable. Okay. So that's the basic idea of recurrent neural network. So for the next lecture, we'll also continue to talk about recurrent neural networks, specifically LSTM, and we'll also talk about the attention mechanism and finally the vision transformer, which is very popular in recent years. So after next lecture, that will conclude our discussion on deeper neural networks, and we'll talk about some of the topics in deep learning and how they applied in medical image processing. Hopefully, these 4 lectures will give a basic idea, right? What different networks, and then you are able to use that knowledge to reading papers and helpful for your project. Okay.